Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. So there are different power supply versions, ranging from ATX 12 volt 1.3 and ATX 12 volt 2.0. 1.3 was the first widespread update to ATX PS, whereas now most modern PCs are using ATX 12 volt 2.0, mainly because it provides multiple 12 volt rails. However, be sure to read the manual because some cheaper power supplies don't necessarily obey this rule. With the 1.3 standard, it also introduced a 6-pin auxiliary connector. The connector was based on the motherboard power connector. However, a few motherboard makers skipped adding their connector and used a standard Molex connect so people with older power supplies wouldn't have to upgrade just because they bought a new motherboard. Here you see a 20 and 24-pin power supply connector. This is an example of a PCI Express 6-pin power connector. There are, however, some form factors that use what we call a niche market power supply. Those are identified as either TFX, SFX, CFX, or LFX. In more of the high-end power supplies, you'll have what's identified as active PFC, or power factor correction. Basically, it eliminates the harmonics or the electronic noise the power supply puts into a PC. So what are the wattage requirements of your PC? It's important to remember every device requires some wattage. Power supplies don't run at 100% efficiency. For instance, ATX 12 volt require power supplies to be at least 70% efficient. So a general recommendation is to use a 500 watt power supply. That will provide enough extra wattage for starting and future growth. Now let's look at how to install and maintain your power supply. The process really is pretty easy. First, remove the old power supply. You're going to disconnect the wires, remove 4 standard screws, and then remove the power supply unit. Next, to install, place the power supply unit in its proper place in the case, replace the 4 standard screws that you removed prior, and then connect up all the wires. Remember to check your voltage setting on the back, and a little trick to just dissipate any residual power is you can short the power by using a key on the on-off jumpers. Next, you need to understand cooling. The power supply fan provides basic cooling to the PC. The fan keeps the voltage regulators cool and provides a constant flow of air through your computer. If the power supply fan stops, you'll need to replace the entire power supply. Most modern computers have what's called case fans. They often plug into a Molex connector. It's important that you keep your case closed. Keep the cover on the case. While you think you may be getting more air into the case, you're also introducing dirt. Remember, without proper airflow, the CPU can overheat, and that would cause overall destruction. Some fans can be rather noisy. Some of them can be adjusted either manually by adjusting a knob or via software that will adjust by the heat setting. Larger fans that spin more slowly are generally quieter. And a basic rule of thumb really is higher end fans are just quieter because they're using better bearings. Some fans even come with options like allowing CMOS to monitor the PC's health by showing its temperatures. It doesn't control the fan, but it will at least let you know if there's a problem. So what causes a power supply to fail? Basically, there's two ways. Either sudden death, when the fan doesn't turn and no voltage is present, the computer just simply stops working. Or slowly over time. So the way to test your power supply is you'll use a tester. Remember, power supplies need a load. So you take an ATX power supply tester, plug your power supply into one side and the other side into the motherboard. With intermittent problems, which means sometimes it happens and sometimes it doesn't, you could measure voltage now and it's good, and then 10 minutes later it all crashes. Some symptoms of a dying power supply are random lockups and reboots or sporadic boot up difficulties. Whenever you encounter some of these intermittent problems, it's probably a good idea to just go ahead and replace the power supply now, because you're going to need to eventually. Now let's talk about safety. So whenever a circuit breaker is tripped, that means there was excessive heat produced. These fuses blow for a reason, probably because the power supply itself is malfunctioning. Absent a circuit breaker, the alternative is fire. The A+ examination expects you to know and understand what type of fire extinguisher to use in case of a fire. Here's a quick, easy way to remember them. Class A fire extinguishers you'll use for combustibles such as paper or wood. Class B is used for liquids, and Class C is used for electrical fires. Here's a trick to keep them straight. Class A for ash. Class B for boiling. And Class C for circuits. Now you know which fire extinguisher to use for which type of fire. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.